Welcome to clickmyproject.com. Here we discuss about an ANFIS based SHEPWM in multi-level inverter. Inverters, which is used to convert the DC input to an AC output voltage. These inverters are used in various home appliances applications today. So, to produce the maximum output voltages, we require suitable technique to minimize the harmonic present in the output signal. Harmonics, which is called the associated components to the fundamental, is called harmonics. So to the elimination of harmonics, various PWM techniques are available. Sinusoidal pulse width modulation, carrier based sinusoidal pulse width modulation, and space vector PWM techniques, etc. But in certain applications, if the application is sensitive to harmonics but can tolerate the switching losses, high switching frequency PWM is preferred. Similarly, if the application is sensitive to harmonics but cannot tolerate the switching losses, low switching frequency PWM is preferred. In SHEPWM, the optimal minimization of total harmonic is implemented. For that purpose, we are using generalized half-wave neural network to solve these equations. Then, the program in C was developed to solve the system of ordinary differential equations. How these equations is formed? Inverter output voltage is represented as Fourier series analysis expression. This expression is called a nonlinear transcendental equations. The solution of these equations corresponds to the switching instance to the required problem. The problem here is redrafted as an optimization problem. To solve the problem, we get 5, 7, 11th and 13th order harmonics are eliminated and the fundamental output voltage kept as desired value. An energy function formulated which describes the objective function of an Fourier series expressions. The Fourier transform analysis is used to solve these equations, and finally we get the fundamental output voltages required value and elimination of harmonics are possible. So the proposed method is validated using two platforms, MATLAB and real-time implementation. In this base paper, the GHN network can be extended to the multi-level inverter technology. So, to solve the problem of multi-level inverter circuit, we take this example in a proposed system. In our proposed system, the process of SHEPWM technique is extended to the 11-level inverter. The 11-level inverter circuit is formed. The MATLAB simulation is carried out for a various modulation indices value. Finally, the switching instance corresponds to the PWM pulses or obtained for a various modulation indices. These switching instance compared with a triangular wave to produce the PWM pulses. These PWM pulses are applied to the inverter switches. Finally, R load is connected to the inverter circuit and the FFT analysis validate the simulated results. Next, the system architecture of an proposed system, which consists of 5 individual blocks. They are modulation index, ANFIS based switching instance, PWM generation, 11-level inverter, FFT analysis blocks. Modulation index is the ratio of an reference signal to the carrier signal, which is given to the ANFIS based switching instance block as an input. The second block receives modulation index as an input and it produces the necessary switching instance for SHEPWM. This switching instance applied to the PWM generation block. The PWM generation block compare the switching instance with a triangular wave and it produces pulses. These pulses are applied to the 11-level inverter circuit. The 11-level inverter circuit consists of 5 subsystems with each number of 4 IGBT switches. Finally, the FFT analysis shows the harmonic reduction and maximum fundamental component. Next, we discuss about the running procedure for proposed system. Our proposed system consists of three important processes: construction of PWM generation, 11-level inverter circuit formation, parameter measurement using FFT analysis. First process, PWM generation. This block splitted into two. One is a modulation index and another one is the comparative units. Then it receives the modulation index ranging from 0 to 1. The switching instance from the ANFIS based block is calculated here. The switching instance are calculated for the various modulation indices using ANFIS based tool. The modulation indices and initial values are given as an input to the Fourier series analysis expression, and the solution of this expression which describes the energy function. The energy function which is formulated based upon the state of GHNN network. The switching instance obtained using ANFIS based training of 100 number of epochs. Overall simulations are validated 3000 number of iterations. This switching instance is again given to the comparative units. Our comparative units, which consist of triangular wave generation and comparative blocks. The triangular wave unit generation produces the triangular wave of an amplitude 0 to 1.57 radians with 20 milliseconds duration. The switching instance compared with this triangular wave, and it produces the positive half cycle pulses and negative half cycle pulses. The positive half cycle pulses are delayed with 180-degree phase shift to obtain the negative half cycle pulses. Second process, 11-level inverter circuit formations. It consists of 5 subsystems. In each subsystem, 4 number of IGBT switches are connected together. Positive half cycle pulses are applied to 1 and 2 of the switches. Negative half cycle pulses are applied to 3 and 4 switches. The R load of an 50 ohm connected to the circuit. The voltage and current are measured using the suitable measurement block. FFT analysis. This is the final process. The number of cycles are set as 1 and the fundamental frequency set as 50 Hz. Using the setting parameters, the FFT analysis has been carried out. The display option shows 5, 7, 11, 13th order harmonics are eliminated and fundamental component to the desired value. This FFT analysis repeated for various modulation indices. The rangings are low, medium, high ranges. The low range of modulation index can be taken as 0.247 and medium range can be taken as 0.685 and the high range 0.95. The DC input voltage of 100 which is applied to each subsystem as an input voltage, and the fundamental component and the reduction of harmonics are analyzed using the FFT analysis. This simulation model confirms the effectiveness of GHNN system, and solving procedure of harmonic using non-transcendental equations are showed. Thank you.